Hello geometers. Today we are going to talk about the elusive CPCTC, something that if you've been in my class recently while we've been doing triangle congruence proofs, some of you may have heard, because some people have been wanting to throw it out there. People who have had this material before, who have done triangle congruence proofs and the like before, have been saying, oh, maybe this is CPCTC, maybe this is where I throw it in. So those of you who haven't done things like this before have probably been confused about what they're talking about. And quite frankly, any of the people who have thought this must be CPCTC are having a little bit of confusion about what CPCTC stands for or is themselves. So you also need to pay attention to this, okay? Because we haven't addressed it till now. We haven't needed it until now. So if it's come up, it has come up in error. So let's talk about this. Three things we're going to answer, three questions we're going to answer. We're going to answer what is it, how do I use it, and when do I use it, or kind of when or where do I use it. All right, first thing is CPCTC is an acronym. An acronym is a set of letters like, oh, I don't know, suddenly I can't come up with a good one, but it's a set of letters that stands for a phrase, or in this case, a sentence. So it's basically just the first letters of the words. It's just this sentence. This is what CPCTC is, this sentence. And this sentence, basically, we treat it like it's a theorem. It kind of is. Okay, corresponding parts, CP, corresponding parts. That means the parts that go together, the parts that match, the parts that like, for instance, the angles that go together, or the bottoms of the triangles, or the heights of the triangles, the things that would match up, the things that we would pair up. So corresponding parts are the parts that go together of, okay, congruent triangles. Congruent triangles, we know that those are triangles that have all the same side lengths and all the same angle measures, are congruent. Okay, so here's my CPCTC. CPCTC. All it is just a sentence that just tells us that if we know that triangles are congruent, if I know that I have congruent triangles, then their corresponding parts must be congruent. It's just kind of like when we very first started talking about triangle congruence, we said, if this is true, then that means that AB is congruent to KL, or angle CAB is congruent to angle MKL. Basically what I'm doing is I'm saying if I know that the triangles are congruent, then I can say that any pair of parts that goes together, like AB and KL, or angle A and angle K, or angle CAB and angle MKL, any of the parts that go together have to be congruent. So I'm not really saying anything earth-shattering. And we got to be careful about when we use this, because sometimes people get confused about when we use this. I'm going to see if I can make it a little bit. No, I can't. Sorry, it seems a little bright to me, but hopefully it's not giving you eye strain. All right, so first off, when would we need this? Well, we would need this when we want to talk about parts being congruent. That's when we would need it, because that's what it says. It says that corresponding parts are congruent. And this little of congruent triangles is basically saying, it's almost like it's in parentheses. We have to know that triangles are congruent first. And if we know that we're working with congruent triangles, then we can say, oh, okay, then the corresponding parts are congruent. Okay, so for instance, let's look at this proof. I think it's on the back of the sheet. There we go. Here's a proof. We are given that MN, segment MN is congruent to segment PQ, segment NO is congruent to segment QR, and segment OM is congruent to segment RP, and these are all marked. The corresponding parts are marked. Okay, so MN corresponds to PQ. That's what we mean by corresponding, the ones that would go together. Here's what we're being asked to prove. Okay, so the important thing to recognize is, just like we just said, we only use it when we're being asked to prove that parts are congruent. These are parts of the triangles. These are not whole triangles. I would not use it to prove whole triangles are congruent. I can't use it to prove whole triangles are congruent. I have those other 5 methods for that. These are the methods I use to prove that entire triangles are congruent, right? That's not what I'm doing here. It's not what I'm being asked to do. I'm just being asked to prove that one pair of corresponding parts would therefore be congruent if all these other things were true. So we have to know that we have congruent triangles in order to use this. Again, it's corresponding parts of congruent triangles. We have to know that we have congruent triangles, or else we don't know that the parts are congruent. Which means this: I have to see one of those in my proof, or else I don't have an opportunity to use CPCTC. I can't say that corresponding parts of my congruent triangles are congruent until I actually have congruent triangles. So I have to see a triangle congruent statement somewhere in the proof before, could even be given, but I have to have that information somewhere before I would ever think about using CPCTC. So that's an important thing about when I'm going to use it. So we've talked about how to use it is to prove that parts are congruent. So this is saying I need to know that these parts are congruent. And right here it says you can tell that these parts are congruent by CPCTC. So CPCTC tells me that parts are congruent after, and this is when and where to use it, after I already know that the triangles those parts are in are congruent. Okay, here's another example. Okay, this one I am given that SU is congruent to UV. So I'm given this right here. And then I also know TU is congruent to itself. So I know that these two triangles are congruent by side angle side. Okay? Ooh, actually I don't even, You know what? They incorrectly used a proof, didn't they? Look at that. Or used a reason. I know that these triangles are congruent by side angle side. Let's talk about that. I wasn't asked to prove that the triangles are congruent. But if I can prove that the triangles are congruent, then I can pick any pair of corresponding sides or angles and say, okay, now I know these are congruent also by CPCTC. So that's why, in order to say this, ST is congruent to VT, this part here and this part here, I'm going to first figure out if I can tell that these two triangles are congruent. And I can, and I said by SAS. Why is it not by HL? Think about why it's not by HL. Why is this wrong? Because this is what we're being asked to prove. ST is congruent to VT. Those are the hypotenuses. So we can't use hypotenuse like if we don't know the hypotenuses are congruent. So this particular proof is wrong. I can't use that. And I can use side angle side. I've got two pairs of sides and the angles between them. And I really now need a separate step to go in here instead in front of step 3 before I can make the triangle congruent statement. I need to say angle, let's see, angle SUT is congruent to angle VUT by the right angle congruence theorem. It's the thing that just basically says all right angles are congruent. So since I know those are both right angles, I know that they'll be congruent. So now I have SAS. So now I'm going to say for step 3, SAS. Now why did I prove the triangles were congruent? The whole point of proving the triangles were congruent was so that now we could say, okay, now if you want to pick any sides you want to pick, any angles you want to pick, as long as they're the ones that go together, the corresponding ones, then I can say, yes, they're congruent because they're in these two triangles. So because corresponding parts of congruent triangles are congruent, I know that these corresponding parts, ST and VT, of these two congruent triangles are congruent. And again, it is really, really important to note that I did not use this until I had already had a triangle congruent statement. So I have to know, and I have to have stated, that the triangles are congruent before I can use CPCTC. Another thing is, remember, we don't ever use a triangle congruence statement without one of these, because these are the way that we prove triangles are congruent. By side angle side, or angle side angle, or one of those. All right, let's do one from scratch. How about, this one's pretty straightforward. It says, given that angle U is congruent to angle V, and those are marked, angle T is congruent to angle W, and those are marked, and side TU is congruent to side VW, they want me to prove, now it doesn't say prove that the triangles are congruent, it says prove that these other angles are congruent. But the easiest way for me to do that is going to be, and I'll need to grab my pen, to prove, hang on, that the triangles are congruent. And once I can prove that the triangles are congruent, I can use CPCTC to go from there. So I'm going to say, let's just go ahead and list them one at a time. I know that pair of angles is given, or is congruent because that's given. I know this pair of angles is congruent because it's given. And I know that the pair of sides here, TU, is congruent to VW because that's also given. Now let's just stop for a second and recognize what we have. We have a pair of angles, another pair of angles, and a pair of sides. Okay, we have to decide whether it's AAS, which is the same as AAS is the same as SAA, or ASA, because both of these have two pairs of angles, one pair of sides. The whole thing, remember, it doesn't matter order that I wrote them in. It doesn't matter order going around the sides. What matters is, where is that pair of common sides? Is it between the angles? Is it the included side right in between the angles? So that if I go from one of the angles vertex to the other angles vertex, it's the side. And yes, this is the included side. So my answer for saying, my reason for saying that these triangles are congruent, I'm going to say STU is congruent to triangle, let's see, S goes with X, T goes with W, U goes with V, by what? It's the included pair of sides, so my reason for saying those triangles are congruent is ASA. Now, there was my triangle congruent statement. Here's my reason, my triangle congruence postulate or theorem. I have said the triangles are congruent, but that's not what I was asked to do. The only reason I did that is what we call a means to an end. I did that so that I could go on and say, there. Now I know everything about these triangles has to be congruent because I just said the triangles are congruent. So that means any pair of parts you want to pick, as long as they're parts that go together, and angle S and angle X are, those are corresponding parts. So corresponding parts of congruent triangles are congruent. So CPCTC is just an abbreviation. It lets us basically say that entire statement, that entire sentence without writing it out. Okay, I want to go off paper here and look at another one that is kind of useful. Let's talk about a rectangle for a second. Rectangle has what kind of angles? Has 4 right angles, right? That's really kind of the definition of a rectangle. I've got 4 right angles. And here's what I'm going to say, let's given rectangle ABCD. In other words, it's given that ABCD is a rectangle. Okay? Which is basically, by definition of rectangle, will tell me that all the angles are right angles. So that's my given, and I want to prove that segment BD and segment AC have what relationship? What relationship should AC have to BD? They should be congruent. Okay? So I'm going to prove that. Now here's how I'm going to do it. I'm going to use congruent triangles. And congruent triangles I can use for a whole lot of things. especially now that I have CPCTC that helps me use the fact that the triangles are congruent to say almost anything else I want to say. All right, so what I'm going to do is I'm going to look at two triangles. One triangle I'm going to look at here is I'm going to look at triangle ADC. Okay? The other triangle I'm going to look at is BDC. Okay, and just for to help myself out, I'm going to draw them separately. I would do it over to the side of my paper, or in my case, obviously I'm using an index card, so that I can make sure I see what's going on in each of these two triangles clearly, because they overlap. Anytime they overlap like that, it can be really helpful to pull them apart. Okay, one thing I know is, well, I know I've got a pair of right angles. So let's go ahead and say ABCD is a rectangle. That was given. And I'm going to say that angles D and angle C are right angles. And I'm going to say that by the definition of rectangle, because that's what defines a rectangle, is that I have a quadrilateral, a four-sided figure with four right angles. Now I'm going to say that means that D and C are congruent because of the right angle congruence theorem. That's the one that says all right angles are congruent. Okay, so I've got one thing ready to go. I've got one pair of congruent angles. What else is congruent on these two triangles? How about DC is congruent to itself? So there's a pair of sides. Okay? DC is congruent to itself by what? That would be the reflexive property of congruence. I'm just going to say reflexive. Okay, so now this is what we've got. We need at least one more thing here to be able to say these triangles are congruent. Okay? We can't use that AC is congruent to BD because we don't know that. That's what we're actually trying to figure out. We're trying to figure out how to prove that. Okay? But what about these two sides? Okay? Turns out that one of the properties of rectangles, another property of rectangles, and I would kind of, in order to do the proof this way, we'd have to assume that we already know it. So let's do that. Let's assume that we already know that opposite sides of a rectangle are congruent. Okay, that's actually true. That's something that's true for every parallelogram. Opposite sides are congruent. And we're going to prove that pretty soon, as a matter of fact. But let's go ahead and say that AD and BC, because they're opposite sides of the rectangle, are congruent to each other. AD is congruent to BC, and we're going to call that just a property of rectangles. Property of rectangles. Really, we could say, the other thing we could do here is just write it out. Opposite sides of a rectangle are congruent. I could write that right here, or abbreviate it. Opposite sides, let's just do that, are congruent. Okay, because there are other properties of a rectangle, so we wouldn't want our reader to be confused. Okay, so now, what do I have here? I have that these two triangles are congruent by what? I know the triangles are congruent. Triangle ADC is congruent to triangle BCD by side angle side. But we're not done, because that's not what we're trying to prove. We're trying to prove that these sides that don't show anything, the hypotenuses of those two right triangles, we're trying to prove that those are congruent. Well, now we know that they are because they're corresponding parts of two triangles that we already know are congruent. So by corresponding parts of congruent triangles are congruent, which is otherwise known as CPCTC, I can tell you that those parts have to be congruent. And that's my proof. That basically, what have I proven? What parts of the rectangles are A, C, and BD? basically what I've proven here is I've proven that the diagonals of a rectangle are congruent. And that's true. That's a theorem. How do I know it's a theorem and not a postulate? Because I can prove it. I just did. Theorems can be proven. Okay? So opposite sides, so diagonals of a rectangle are always congruent to each other. And that is a truth, a property, a theorem about rectangles that we just proved using congruent triangles followed by CPCTC.